Morning. I am Pradesh Kumar, working as Assistant Professor, Department of ECE at KS Navi College of Technology. Today we discuss the topic on smart antennas. The smart antennas are antenna arrays with smart signal processing algorithm used to identify spatial signatures such as the direction of arrival of the signal. So the smart antennas are activated by using smart signal processing algorithms in order to find out the desired signal. It used to track and locate the antenna beam on the mobile target. It adaptively changes its radiation pattern to improve the signal reception. It minimizes the interference and increase the capacity. So by employing these smart antenna techniques, it uses the beam forming process and direction of arrival estimation. So smart antennas can focus signal towards desired users and avoid the interfering sources. It significantly enhancing the performance of wireless communication system in complex environments. So why we want to use the smart antennas? To improve the wireless communication system by providing increased coverage range. So it covers the coverage range at populated area. So it forms the concept of beam forming to improve the signal quality and data rate using the beam forming and adaptive signal processing techniques. They offer significant benefits such as reduced interference, enhanced spectral and energy efficiency, and greater capacity to handle multiple users simultaneously. So the aim of smart antenna system is to maximize the antenna gain in the desired direction. See the figure, and the desired users can access this smart antenna system where interferers cannot able to access the systems. So dynamically adjusting the directional patterns to enhance the signal strength. So this smart antenna can activate the beam forming techniques, beam forming in the specific locations. So increasing capacity and range, reduce the interference and improve the spectral efficiency. So the types of smart antenna systems are switched beam antenna and adaptive antenna array. In switched beam technique, a finite number of fixed predefined patterns are produced. So in adaptive antenna array, infinite number of patterns based on the scenario, they are adjusted in real time. First we see the switched beam antennas. The switched beam form multiple fixed beams with heightened sensitivity in particular directions. The switched beam systems have several available fixed beam patterns. A decision is made in which beam to access the given point of time, so based upon the requirements of the system. So the particular beam will be activated whenever we need to use the particular location. So as the mobile unit moves throughout the cell, the switched beam system detects the signal strength and continuously switches the beam as necessary. So which beam we want to activate that particular beam in the mobile users in the target area. This is a figure shown as there is a multiple beams which used to activate when there is a mobile user. So it subdivides sectors into many narrow beams. Then each beam is considered as individual sector, saving user or group of users. So block diagram of switched beam system, which has RF switch, phase shifting networks, detectors and control logic. So phase shifting network which forms multiple beam looking in certain directions. So RF switch activates the right beam in the desired direction. The selection of right beam is made by control logic, which is governed by algorithm. So direction of arrival algorithm is included for the signal receiver from the user. So this algorithm which scans all the beams. So now there is a stronger signal, it used to activate that particular beam. So the overall goal of the switched beam is to increase the gain according to the location of the user. So in adaptive array antennas, systems are really smart because they are able to dynamically react to the changing RF environment. They can detect the main beam towards signal of interest. While suppressing the antenna pattern in the direction of interference, it can customize an appropriate radiation pattern for each individual users. So dynamically adjust the antenna pattern to enhance reception while minimizing or fully rejecting interference. So adaptive antenna array can adaptively changes the beamforming position. So this provide optimal gain while simultaneously identifying, tracking, and minimizing the interfering signals. So there are two different signals. One is the interference signal and user signal. So it avoids the interference signal and give more signal strength to the user side signal. So the concept used is the multiplexes technique is space division multiplexes. So from this space division multiplexes, so beams are sliced to keep different users in different beams at same frequency, which allows frequency reuse concept. This technology achieves superior level of interference suppression and reduces RF pollution. The comparison of switched beam and adaptive arrays. In integration, easy to integrate, implement in switched beam. In adaptive arrays, transceiver complexity design problem, and it has high cost. So coverage range, switched beam have more coverage compared to conventional system. So less coverage compared to adaptive array. So in adaptive array, the coverage compared to switched beam is more. Then the next criteria is interference rejection. In switched beam, difficulty in distinguishing between desired signal and interference signal. It does not react to the movement of interference. In adaptive arrays, focusing is narrower, so capable of nulling the interfering signals. So it can reject the interference signals. So advantages of smart antennas: enhance coverage through range extension, fully controllable by software, so less manual operations. So reduction in transmitted power, reduce co-channel interference and multipath interference, provide high security, improve system capacity, and highly compatible, which can use the following techniques like TDMA, FDMA, and CDMA. So drawbacks is the transceiver block is more complex than traditional base station transceiver, and it is highly expensive. So applications are used in cellular and wireless networks and satellite systems. So the smart antenna market segmentation. So the two types are used: switched multi-beam antenna and adaptive array antenna. So technology uses MIMO, MISO, and SIMO, SIMO. So MIMO is the multiple input, multiple output techniques. MISO, multiple input, single output, and SIMO, single input, multiple output technologies. So applications uses Wi-Fi system, cellular system, WiMAX, radar, and others. So conclusion, so smart antennas are intelligent antenna system that vastly improve the efficiency of wireless transmission. Smart antenna can achieve high data transmission rate and highly coverage with reduced multipath and co-channel interference. So smart antenna system are software controlled and remotely configured. So promising technology to resolve the traffic capacity. So students can go through this videos and can answer the questions. So smart antenna related MCQ questions. Thank you.